Hello and welcome to the Sunday Short Story Webcast. I'm your host, Aubrey Adrianson, and for today's episode, we're taking a little break from looking at religious texts, and instead we're delving into science. Today I will talk about the Big Bang, and I've recruited my daughter, Aura, as the audience. Her job is to react to this information in her normal childlike curiosity and to demand evidence. Basically, I want her to be critical. So first, a little explanation of the Big Bang, and this is really condensed. The Big Bang Theory explains how the universe began. There is some debate on what happened moments before the Big Bang or what caused the Big Bang, but we don't know for sure. We know it happened about 13 billion years ago, and what happened was a tiny fraction of a second after the Big Bang, the universe started expanding. And this universe, 13 billion years ago, was extremely hot and dense. And particles began to form in this hot, dense universe, as did our basic laws of physics and gravity. And through the force of gravity, those particles became attracted to each other and other objects and eventually formed stars, planets, moons, etc. And the universe continues to expand, and it has cooled since the Big Bang. So now that we have life out here on Earth. So that's just a really condensed version of the Big Bang. So now, Aura, do you have any questions?
What caused the Big Bang?
Well, we don't know. There are many hypotheses, but there isn't enough evidence for any one hypothesis for the scientific community to say, yes, that's how it all started. Scientists are still studying the origins of the universe. And you have to understand, it's okay to say, I don't know, especially if that inspires you to go find the answer.
How do particles like a hydrogen atom have gravity?
Well, everything has gravity, and gravity is determined by mass. The more mass an object has, the more gravity it has. Atoms don't have much mass, but they have some. They move closer to each other through gravity and can make what happened was they moved closer to each other through gravity and eventually made large dust clouds that eventually turned into stars. Or what they can do is they can move together and make molecules like water, which have 2 hydrogen atoms and 1 oxygen atom.
How do we know this is true? We weren't there when it happened, so where's the evidence?
Scientists develop this theory through evidence, which is true of all scientific theories. For the Big Bang, there are 3 pieces of evidence that are relatively easy to understand. First, scientists have observed galaxies moving away from each other. The universe is expanding, and we can measure this with a telescope. And the galaxies are speeding away from each other in a straight line, all from a point of origin. Second, scientists have observed the radiation signal from the event. An explosion of that size would leave a radiation signal, and it is still present in the universe. A third piece of evidence might be the hardest to understand. After the Big Bang, the only element in existence, or the first element that was formed, I should say, was hydrogen. And this was a very dense environment, and like the environment the universe began in. And because it was so dense, the hydrogen atoms could fuse together. They could move together and make a new element called helium. So it happened kind of in the beginning of the universe a little bit, but it still happens now inside of stars. And all of the other elements we find in the universe today are also made in stars. So anyway, shortly before a star's death, it can push like 2 helium atoms together to make carbon and so on. So that's how we get all these different elements. So anyway, scientists have been able to calculate the amount of hydrogen and helium in the universe. And by measuring those amounts, they have been able to support the Big Bang Theory. Like I said, it's a little difficult to understand, but basically what scientists are saying is based on this theory, we should expect to see a certain amount of hydrogen and helium in the universe. They were able to go out and measure that amount of hydrogen and helium, and they found it to be true.
Is there any evidence that I can observe?
So evidence that you personally can observe is a little tough. Scientists use very expensive, very powerful, and very specialized telescopes to gather all this data that I just talked about. And unfortunately, access to this equipment is very limited to someone who is not conducting research. In addition, you have to be trained to know what to look for. This is likely one of the reasons why the Big Bang Theory is hard to accept by people outside of the scientific community. However, if you are able to look through a powerful enough telescope, you should be able to at least observe the galaxies moving away from each other with relatively less scientific training than some of these other pieces of evidence that I talked about. The best thing to do is read up on the evidence and educate yourself. So that's what I have for you guys today about the Big Bang. Definitely keep educating yourselves and gathering that evidence. There are some additional resources on the website. Please go check them out. Thank you.